Hello everyone. So in our previous video we discussed about that how we can delete a node from a singly linked list at a given position. So in our last video we saw the animation of the algorithm step by step. Now in this video we'll actually code the algorithm and we'll test its working. So in our singly linked list class, which has a head of type list node as an instance variable, here we have coded many methods which are part of singly linked list. Now here I will be coding the method as delete, which will take in a position, and based on that position that particular node will be deleted from the singly linked list. So let's say I give the method name as public void delete, which takes in a position. So friends, here you can even return the list node which you just deleted via this method, but I am keeping it as void. And here we are assuming that position is valid and starting from 1. So let's say for example our linked list has few nodes such as 3, 4, 7, 8 and let's say 9. Now here you can see the linked list has 5 nodes, 3, 4, 7, 8 and 9. So 3 is at position 1, 4 at position 2, 7 at position 3, 8 at position 4 and 9 at position 5. So let's say if we want to delete the node from position 1, so this node will be removed and then linked list will have these nodes. If we want to delete a node which is in between, then let's say if we want to delete node as 3, so 7 will be deleted and the remaining list will be 3, 4, 8 and 9. Here 4 will simply point to 8 and 7 will be removed from the singly linked list. And let's say if we want to delete the last node, so here you can see as there are 5 nodes and if we pass the position as 5, then 9 will be deleted. So let's see the algorithm. So based on our assumptions that position is valid and starting from 1, we provide a if else condition. The first step we check whether if position is equal to 1, which means if position is equal to 1, it means that we are simply removing the first node of the singly linked list. So here as head is pointing to the first node, after its removal head should point to the second node. So we'll simply assign head.next value to head. So for example here if you see head is pointing to node 3 and if you want to delete the node from position 1, then after node 3 gets deleted our singly linked list will become 4, 7, 8, 9 because head will now point to 4. So we can simply do head equals to head.next, which will assign the next value, which is this value, to head. So this is the first case. So in the else part we will see that how we can remove a node from a singly linked list which is in between of these nodes or at the end of the singly linked list. So both these cases will be covered in else part. So here let's suppose if we want to delete the fourth node which is at position 4. Now the idea behind this algorithm is, which we also discussed in our previous video when we did for the insert. Here what we do is, in order to remove 8 from the singly linked list, we need to break this linkage from 7 to 8, and instead of 7 pointing to 8, 7 should now point to 9. And once 7 will point to 9, 8 will be removed from the singly linked list. So in order to break this linkage, we need to first traverse to this node which is just behind this node, because we need to use this reference, remove this reference link and make sure that 7 now points to 9. So in order to reach the previous node from 8, what we do is we simply create a temporary list node previous and we start it from the head, and then we'll provide a while loop so that we can reach to this node. So how we can reach to this node is, we will create a counter variable, and as previous is already pointing to head, we'll assign it with 1. And now using count and position, we will reach to this node. So in the while loop, we provide condition as count should be less than position minus 1. So when count is less than position minus 1, this while loop will keep on iterating, and with each iteration, we'll simply traverse previous to its next position by assigning previous.next to previous, and we'll simply increment count by 1. So friends, when previous will reach to node 7, the value of count will become 3. And here you can see we pass the value of position as 4 because we want to delete 8. So 4 minus 1 is 3. So 3 is not less than 3. So after this while loop will terminate, in order to assign 7's next to 9, because we want to break this linkage here, what we do is we first reach to 8. And how we can reach to 8 is, here you can see previous is already pointing to 7 because we have reached to 7 in this while loop. So here we'll create a temporary node current, and we provide the value as previous.next. So this is the previous, and if we do .next, we will reach here. So current will point to node having value as 8. And now as we want to point 7 next to 9, what we simply do here is, to previous.next, which is currently pointing to 8, we will assign the value as current.next, because current next is pointing to 9. So now 7's next will point to 9 instead of 8 via this line. So after this line, this link will be gone, and there will be link from 7 to 9. So 8, once this method gets terminated, 8 will be garbage collected. So this is the code to delete a node from a singly linked list from a given position. So in our main method, now let's test its working. So here in our previous video we discussed about the insert method. So let's say if I run the code, you see currently the linked list has 5 nodes, 2, 4, 3, 5, 7. So we'll use the same linked list and we'll delete the first node, the node in the middle, and the last node. So here if I do delete 1, which is at position 1, so this is the singly linked list which we saw while running the program. So 2 will be removed. So let's run it. So here you can see it printed 4, 3, 5, 7 because 2 got removed. And now let's say now linked list has 4, 3, 5, 7, and we want to remove node 5, which is at position 3, because 2 is already removed, and we are removing 5, which is at position 3. So we'll call delete with position 3. So now it should print 4, 3, 7 because 5 will be removed. So here you see it printed 4, 3, 7. Now we have 4, 3, 7, and let's say we want to remove the last node, which is 7. So 4 is at position 1, 3 is at position 2, and the last node 7 is at position 3. So we'll again call delete with position 3. And if I run, it should print 4 and 3. So here you can see it printed 4 and 3. So friend, this is how we can delete a node from a singly linked list from a given position. And here we are assuming that position should be valid that it should lie into the boundaries of our singly linked list. So friends, I hope you have liked this information, and in case if you like this information, then please like this video, and if you are new to my channel, then please subscribe to my channel so that you never miss any update. Thanks, have a nice day.